Hello everyone, welcome back to Prep Pro Papers. We are solving GS 2022 paper. The part 1 of the general has been uploaded, but there is some glitch for the audio. I'll try to re-upload that. Today we'll be solving for physics section of GS 2022 TIFR JGEEBILS paper. So let's get started. So the first question says, heat and water loss in animals is proportional to the ratio of their surface area to volume. Imagine a spherical cow. When the radius of the cow doubles, its surface area to the volume ratio. So, if we are considering the cow to be 1 minute. So, if we are considering the cow to be a sphere, the surface area of the sphere becomes 4 pi r square. Now the second condition says that if the radius of the cow gets doubled, so first we see that the r now becomes 2r. We need to find out area to the volume ratio. Area is 4 pi r square, volume becomes 4 by 3 pi r cube. Today I am a little out, so you can please ignore the background noises. This will be 4 pi to 4 pi is cancelled. This will become 3 upon r. So if we are increasing this to this value as twice, the new ratio will become 3r upon 3 upon 2r, which comes to be 1 by 2. So the answer becomes half. Let's move ahead. Electromagnetic radiation that is emitted from a nucleus is in the form of. So the electromagnetic radiations is made upon interacting electronic and magnetic fields, but the radiation which the ionizing radiations which comes from the nucleus are due to the unstable ratio of the proton and the neutrons. These nucleus then ejects the matter out in the form of energy. When we see the electromagnetic radiation spectrum, the higher ends ones, the gamma rays and the high energy form of ultraviolet rays are of ionizing radiations. So the correct answer is gamma rays. Next question says, a particle of mass m and initial velocity v is faced with a damping force proportional to the square of its velocity and equal to a v square. In how many times will the particle come to a stop? Okay, so if we see that the damping force, we can write it as F is equal to minus a v square. According to Newton's second law, the mass into dv by dt will be equal to minus av square. This can be written as dv upon dv square to be minus a upon m dt. Integrating both the side, dv upon v square is equal to a upon m dt. This can be now written as minus 1 upon v is equal to minus a upon m plus c. We consider this to be equation 1. We can determine the constant c by considering the initial condition when t is equal to 0 and say velocity is v. Then this equation will become minus 1 upon v will be equal to c. If we consider this as equation 2, so from equation 1 and 2, 1 upon v is equal to a upon m, there will be a t term also, t minus 1 upon v. So when the particle comes to a stop, when v is equal to 0. However, as v approaches 0, 1 upon v will approach to infinite, which indicates that the particle will never come to an exact stop in a finite time. So the answer is option number 4. The next question says electrons can be scattered from the surface of a metal to form a diffraction pattern. This shows that again the factual question. This shows that the wave property of the diffraction phenomena happening at the edge of any surface is due to the wave nature of the light or the electrons, which can be emitted in both the waves and particle forms. Option number 1. The next question comes and says, how are chemical elements greater than atomic mass of an iron are thought to be formed? Okay, so this is formed by a neutron merger and a supernova explosion. Please ignore the background noises. I'm very sorry, but today I'm out. So for the neutron star merger, when two neutron stars collide, they create extremely high energy environment conducive to the formation of a heavy elements through rapid neutron capture. Whereas the supernova explosion says that intense energy and pressure enables the synthesis of heavy elements beyond iron. We'll check upon the other options also. So if the first option says in the core of stars. So in the core of stars, the elements forms are up to iron, not beyond that. In the core of earth, no new elements are formed, only existing elements are concentrated. In the Big Bang, lighter elements like hydrogen, helium and small amounts of lithium and beryllium are formed. Let's move to the next question. A cylindrical glass rod has a length 20 plus minus 0.1 centimeter and diameter 5 plus minus 0.01 millimeter. What is the percentage uncertainty in the calculated volume of this rod? Okay, so to find the percentage uncertainty in the volume of the cylindrical rod, we need to calculate the combined percentage of uncertainties in the both the length and the diameter. So given that we have length is equal to 20 plus minus 0.1 centimeter and the diameter to be equal to 5 plus minus 0.01 millimeter. Let's convert this millimeter to centimeter. It will become 0.500 plus minus 0.001 centimeter. From this, the radius will now become 0.25 centimeter plus minus 0.0005 centimeter. So percentage uncertainty, I am writing this as PU. Percentage uncertainty in the radius will become 0.0005 upon 0.25 into 100 for the percentage. This will come to 0.2%. Now the percentage uncertainty in the R square will now become 2 into 0.2%, that will be 0.4%. Now we know that now let's check upon the percentage uncertainty in the length. Percentage uncertainty in length will become 0.1 upon 20 into 100, that will be 0.5%. So total uncertainty percentage in the volume, as volume is pi RL, Therefore we will take the, for the total uncertainty, percentage uncertainty volume, we will take r square percentage uncertainty, that is 0.4% का square, and in length is 0.5% का square. This will come to under root 0.41, which is approximately to 0.64%. But the answer says 0.9%, but according to me it should be 0.7% if we see the closest answer. If you know the better explanation for this question, I'll be waiting for your replies on the comment. Okay, so the next question says, the returning motion of the boomerang is primarily driven by. So you know the boomerang looks like little this. It goes to a direction and come back in the same place. It is because of the combination of aerodynamics forces and the two arms where the aerodynamic forces will be acting and the gyroscopic progressions. Option number 3. The third question is again a factual question. If the ionization energy of a hydrogen atom is E, when the electron in a hydrogen atom jumps from the first excited state to the ground state, the energy emitted is. So we know that from the if an atom is having E energy in the state, it will emit some energy and plus some energy will be still conserved. So the emitted energy will be less than the original energy. So that is option number 2. Next question says, what happens to the protons in a given sample when an external magnetic field is applied? Again a factual question. We know that some will align to the field and some may not align into the field depending upon the spin they are having. Option number 4 is the correct option. Next question says, 100 photons one after the other are sent to a photon detector that has a quantum efficiency of 0.1. How many times will the detector detect the photons? Okay, so the expected number of detections can be 100 into the efficiency 0.1, that is 10. The square root deviation is given as n into p into 1 minus p, where n is the number of the photons and p will be the quantum efficiency. That will be 100 into 0.1 into 1 minus 0.1 under root. It will be root 100 into 0.1 into 0.9. Root 9 will be equal to 3. So that is option number 2. Next question says, our skin is easy to pinch but very hard to pull apart. Based on this property, which of these curves most likely represents the mechanical properties of skin? Okay, so it's the stress upon the strain thing. We see in the C graph, it's been the stress and the strain are directly proportional and the slope is remain the constant. That means more you will stretch, it will stretch more. In figure number A, it's getting into the negative, that means the deformation is happening, not the case. But in the option number B, if after the certain time the stretch becomes is not proportional to the strain, which is exactly what the elasticity of the skin shows. So option number B is the correct option. I'm sorry for the background noise, but I cannot cancel that today. I'm sorry. So let's continue in the next question. If the energy and the momentum of a ball are E and P respectively, its velocity is scaled as. So energy can be written as half mv square and momentum as mv. We need to find out E upon P will be equal to, when we divide the both, half mv square upon mv. From here this is cancelled, that is half v. So we are seeing that E upon P is equal to half v. V is proportional to E upon P. Option number 1. Both ends of an actin fiber of length L are pinned to parallel surface as shown below. The elasticity modulus is E and the momentum of inertia is I. A load P is applied as shown. What is the maximum load that this fiber can withstand without buckling? It's the simple formula of this is the Euler's formula for buckling. So according to the Euler's formula for buckling, PER is equal to pi r square. Sorry, not r value is not there, fault. Pi square EL upon the initial length L square. So the correct option is option number 3. Let's move to the next question. A particle is performing Brownian motion with a diffusion constant d and has a half-life of tau. The root mean square distance it will be displaced from its starting position before decaying will scale as. So we know that Rm is the root mean square of the random motion happening is root 2 dt. We are replacing the time because the time here says I is in tau. That will be proportional to d tau. Option number 1. The next question says the first 4 harmonics produced by an organ pipe open at both the ends are 50 Hz, 100 Hz, 150 Hz and 200 Hz. Which of the harmonics will remain once one end of the pipe is closed? Okay, this is a tricky question. So you need to be very thorough with the concept of the harmonics being produced in the open pipe with one end closed and when both the ends are closed. So listen carefully. As a closed pipe can only produce odd harmonics. In this case, the given harmonics were both odd and even. See. So there will be no harmonics which will remain once end of the pipe is closed. So the option number 4 is correct. Okay, next is the chemistry section which will be solving in the next part 3. Please stay tuned, subscribe the channel to get the notification of the parts uploading because your exams will be happening on 8th of December. I'll try to upload it as fast as possible. Thank you.